Namaste. Welcome to MLT, the Machine Learning Techniques course. My name is Ashish Tendulkar and I will be your instructor for this course. In this video, we'll briefly introduce machine learning, mainly with its applications in different domains. And I will be talking about my teaching philosophy for this course. Let's begin. In this course, we will study machine learning techniques from a theoretical perspective and implement them with basic libraries like NumPy. This approach will help you to build a solid foundation in machine learning by understanding concepts and their implementations from scratch. However, in real world, we make use of libraries and APIs to implement machine learning algorithms in any programming language of your choice. Python is a popular programming language for implementing machine learning models, and scikit, called as sklearn in short, is a popular Python library that has implemented several machine learning models. Implementation of machine learning models with scikit-learn will be covered in detail along with useful practical tips in MLP or Machine Learning Practice course. MLP runs in parallel with MLT, and both these courses provide a complete picture of machine learning both from theory as well as from practical perspective to the students. Machine learning is one of the important areas of computer science and has gained a lot of traction in the last decade or so. It is a sub-area of artificial intelligence which is concerned with imparting human-like intelligence to the machines, as shown in this figure. Machine learning deals with learning parameters of a model, which is a function mapping input to the output. It also has the ability to automatically detect patterns and learn rules from historical data. These learned models, patterns, or rules are then used for making predictions on new data, which are useful in taking actions that benefit users and businesses. Machine learning algorithms can be further grouped into two major domains. One is supervised machine learning algorithm and second is unsupervised machine learning algorithms. We will learn more details about them later in this course. For now, it is sufficient to know that in a supervised setting, the output labels are included in the training set and they are absent in an unsupervised setting. We will study many supervised and unsupervised algorithms in this course. A few examples include linear regression, logistic regression, decision trees, support vector machines, and neural networks from a supervised setup, and k-means clustering from an unsupervised setup. Machine learning has been successfully used in a wide variety of domains like e-commerce, banking and finance, manufacturing, health, science, agriculture, fashion, communication and search technologies. Besides these areas, there are many more areas that use machine learning to solve business problems. And there exist even more areas with great potential for ML applications. You will be pleasantly surprised to know that all of us use many machine learning powered applications in our daily life with or without being aware of the underlying machine learning algorithms. I would like to introduce a few successful applications of machine learning that all of us use pretty often. Let's look at them one by one. We use search engine of our own choice to obtain information of interest from the internet, and there are many search engines that are listed on the slide. These search engines use machine learning algorithms to rank results for your queries by mining massive search engine logs. It is interesting to note that the search results are personalized based on your own past interactions with the search engine. E-commerce companies use machine learning to learn patterns of purchases based on the past purchases of the user and product searches, again from a very large database. Personalized product recommendations are generated from these databases with the help of specialized machine learning algorithms. Decent product recommendation is a key to a more user engagement that has a potential to increase sales and hence profit. We often use one or possibly more social and professional networking sites. These sites use machine learning for recommending friends, contents, and ranking their search results. The payment apps like Google Pay and PhonePe use machine learning to keep their users safe from fraudsters and scamsters. Banks use machine learning for automated loan sanctioning and insurance underwriting based on the risk profile of the applicants. There are many more applications of machine learning algorithms in banking and finance. Machine learning is being used for stock price prediction by algorithmic trading platforms. Sophisticated computer vision algorithms are used for selecting suitable fashionable clothes and articles for users. Next, I would like to add some interesting industrial and scientific use cases of machine learning. Large-scale manufacturing companies are using machine learning to make sense from the humongous amount of data collected from their processes and plants. This data is used for optimizing processes and detection of wear and tear in critical plant equipment and installations. Such an approach leads to an efficient process, thereby increasing productivity and profitability. The wear and tear data collected through sensors is useful in proactive maintenance of machinery, leading to lower downtimes and hence superior operations. Machine learning is used for advanced scientific problems where machine learning algorithms attempt to model natural processes. It is able to solve the protein folding problem, which is a long-standing problem in biology. Protein folding tries to predict the three-dimensional structure of the protein based on the sequence of amino acid, as you can see in this figure. Machine learning is used in health for detection and diagnosis of certain health conditions like diabetic retinopathy. Here, an eye is scanned with a fundus camera and the resulting image is evaluated with machine learning algorithm for diabetic retinopathy. Apart from such consumer and business applications of machine learning, it is also used widely for many causes of interest to the society at large. These are in general called as social goods applications. For example, machine learning is used in conservation of environment, analyzing camera traps for detecting poachers and wild animals. It is also used for detecting illegal woodcutting based on sound recording and analyzing animal behavior in the wild. One of the cute applications of machine learning was to analyze recording of whale calls and interpreting them for conservational purposes. Machine learning is also used in agriculture to manage farms by providing recommendations for water schedules, pest detection, and yield prediction. There are so many machine learning applications and there would be hardly any area or domain where machine learning has not been applied as yet. At this point, I would like to share my teaching philosophy for this course. I like to think about machine learning algorithms in a modular way that was proposed by Professor David Hand and Professor Petherick Smith in their book Principles of Data Mining. It is a general framework consisting of 5 components. These components are as follows. Training data that describes the data needed to train the machine learning model. It describes the input and output pairs, nature of the output, etc. Model provides a mapping between input and output. Concretely, it is the mathematical representation of the relationship between input and output. The third component is loss function, and loss function captures the difference between the actual output and the output predicted by the model. The fourth component is optimization technique that helps us to optimize loss function in order to obtain optimal parameters or weights of the model. And finally, the evaluation criteria helps us to accurately evaluate the model based on the nature of the output and the label distribution. We'll study these components in greater detail in next couple of videos. This is a powerful tool in your toolkit which will help you to understand any new machine learning algorithm by listing down these 5 components. Each concept in this course will be presented at 3 levels. Intuitive explanation of the concept without any mathematical formula is the first level. Second, we present mathematical aspects including formulas and derivations. And finally, we provide implementation in Python using basic libraries like NumPy. This three-way approach is expected to provide a well-rounded introduction of concepts to the students. It also provides a chance to students who are not well versed in mathematics to learn the concept intuitively and from the coding perspective. In techniques course, we'll be implementing machine learning algorithms from the scratch, whereas in practice course, we'll be implementing machine learning algorithms with tools and APIs provided by the scikit-learn library. There would be practice questions and programming exercises after each video, and at the end, there will be a questionnaire. The practice questions help us assess your understanding of the concept and helps us to make appropriate changes in the way we present our concepts. I welcome you once again to the course and wish you a great career in machine learning. Namaste.